So we have a big stack of parts here all sawed out and ready for machining. So what's the next step? Well, let's take a look at the drawings here, and I think if you look at these three drawings, we have parts here for the base plate, we have parts for the middle plate, and parts for the top plate, and they're all similar shapes and sizes. So we can group them all together and we can machine them all at once. They're all 1.5 inch square, and they all have this this flat on them, 1.25 inch from the pivot hole. Okay, so they all have that in common at this point. So we can treat them all as one part, and we can machine them all at once. I mean, you could machine them one at a time, but it would take you hours and hours. If we lump them all together into 2 equal groups, like this, okay, we have 2 equal stacks of parts. We can clamp them in the vise both at the same time and machine them all at once. It'll save us a lot of time. So how do we go about doing that? Well, it would be tempting just to throw a parallel in the vise like this and drop these guys in. Like that. Line them all up, tighten the vise down, and start machining on this top surface until everything cleaned up. But that's a gotcha. That's something I learned early on, is when you're squaring up a bunch of pieces like this, your first cut needs to be as little as possible. You don't want to, if you throw them in here and one of these pieces happens to be a little bit undersized, and you start taking metal off until all the parts come down to that one and that one cleans up, then all the parts are going to be scrap. So what you need to do is, let me show you a little trick on getting around that. Okay, let's take one of these stacks out, and we'll block this parallel up a bit. Alright. Now, let's just take our square and line these parts up along the right edge. Just push them all against the square like that, so they're all lined up on this side. You can clamp onto them with a vise, make them easier to handle. Then put a clamp on the whole stack like that, so they stay aligned. You can take them out of the vise, and we got all this edge nice and aligned. So let's set this aside and do the same thing to the other stack. Just line them up with your square, get them all in alignment. Throw a clamp on these guys. Alright, now we can take them out and we can throw them in the vise like this with that aligned edge up, all the aligned edges up. Clamp them into the vise, take our clamps off. Now all these are pretty coplanar. Okay, so it won't take much at all to clean them up. And we don't have to worry about taking too much off and making all our parts undersized. Alright, now we're going to be using a fly cutter to machine these guys. So let me get that put in the spindle. First things first, we're going to be working with rotating machinery now, so there's no long sleeves when you're working with rotating machinery. If you happen to get a sleeve caught in an end mill or a drill, it'll wrap up and it's going to ruin your day, because the harder you pull on it, the harder it's going to grab, and I guarantee you're going to lose. This machine has enough power to take your arm completely off. So make sure to roll up your sleeves or take any long sleeve shirts off before you work around rotating machinery. Another thing we need to be sure we're wearing is safety glasses with side shields. We're using a fly cutter. These things are infamous for throwing chips everywhere. I mean everywhere. If you're not wearing glasses, or you're wearing glasses without side shields, your chances of getting a chip in your eye are pretty darn high. So get yourself a good pair of safety glasses with side shields. Save yourself a trip to the emergency room. Okay, so we're set up here. Let's let's clean up this top surface. Turn on my 3-phase. Alright, before we go any farther, let's talk a little bit about RPM. What kind of RPM do we run this fly cutter? Well, if it were an end mill, I have a video out on calculating RPM from and cutting speeds and RPM, and there's a formula for that. That's basically you take 4 times the cutting speed and divide it by the diameter of the tool. That's great for an end mill or for like on the lathe. For fly cutter, you can go a lot faster than that because it doesn't heat up like an end mill. So for an end mill, I'd use maybe 250 surface feet per minute. For the cutting speed, I think I'm going to use 500 for this fly cutter. So 4 times the cutting speed, 4 times 500 is 2,000 divided by 2. That's 1,000 RPM. That's what we're going to set it at. Somewhere right in there. Now let's go ahead and clean this up down to the lowest part. You can see why I suggested wearing safety glasses with side shields. Those chips get everywhere. They ricochet off things and they're hitting you in the face. And it's just a really good idea to have the glasses with side shoes. Alright, there's our first cut. Let's see here. Well, we have the parts in the vise. I like to use that opportunity to get the chips off the edges. It's a lot easier than doing them individually afterward, especially the corners when we get to that point. But that's the first cut. So now what we have to do is flip them over and do the opposite side. Alright, keep losing my tools here. Here's a brush. Alright, make sure all the chips are off the parts and off the parallel. Set them back in. Okay, now we don't have to have a nice even side for them to rest on, so we don't have to worry about alignment. Just clamp them down and let's take a clean-up cut on this side. We'll start using the power feed since it's there. I'm getting tired. Alright. Notice I didn't hammer these down when I set them in. It's because they were all different heights. So now that they're cleaned up, I can go ahead and tap them all down so they're tight in the parallel. If you rest your fingers on the side of them when you're hammering on them, you can feel when they seat down. They'll stop vibrating. Alright, so now that they're hammered down, let's take a cleanup cut on them. Then we can set our dial to 0 on the table, measure them, and see how much farther we have to go. Alright, so now we can pull them out, do a quick measurement, see how much more stock we have to remove to take them down to that 1.5" diameter. Okay, we're at 1.534 now. We got 34 thousandths to go. Since we loosen the vise, we have to hammer them down again. Every time you loosen it, you got to start over. Alright, now, before we move anywhere, let's just zero out our dial on the table to 0. And we'll crank up, let's see, crank up 34 thousandths. That'll take them down to the right size. Alright, so these should be down to size. Let's give them a quick check, make sure. Okay, 1.501, that's good enough. Yeah, that's a good point. Let's talk about tolerances on a print. Okay, if you look at these 1.5" dimensions on this part, notice they're 2 place dimensions. That means they have a pretty loose tolerance. Looking down here in the title block, you can see a 2 place decimal has a plus or minus 15 thousandths tolerance on it. So we can go anywhere from 1.485 to 1.515 and still have a good part. So you don't have to waste time trying to get the dimension right at 1.5". Okay, you can get close and move on to another operation. Don't waste time dwelling on that 1.5" trying to get it right on the money, because it's not necessary. It's only necessary to get it as within the tolerance that the print calls out. Alright, so I had another camera issue. Just about the time I was finishing up these the stack of blocks and ready to I finished 2 edges, I was ready to square up the 3rd edge, and the camera quit. So I'm going to have to recreate this here, because I finished up the parts, not realizing it. So I guess the added bonus is you get a little more of a close-up this time around, so hopefully you can see what's going on. So here we are, we got a stack of blocks. It's not all of them, but that's the way it goes. I got the first 2 sides parallel with each other and to size. Now we need to rotate them and clean up the 3rd side square to the first 2. So anytime you do a number of parts like this, it's always good to, as I said before, it's always good to remove as little of material as possible in the first cut, so you don't end up scrapping out the whole stack. So all I do is just throw them in the vise, line up one edge with a square like this, snug the vise down a little bit, and just throw a clamp on the stack to keep them in alignment. Tip them up on edge, and just use your square. And square them up, lock them down, and you can take your clamp off and go ahead and mill. So So now see, we have a nice, all these edges are nice and lined up, so it won't take much stock at all to clean them up. Let's go ahead and do that. Okay, so now we have two sides, first two sides parallel, we have the third side square to those. Now's a good time to take the burrs off these corners because they're all lined up. Do them all at once. I like doing parts all at once, saves a lot of time. Alright, now all we gotta do is flip them. Make a cut on this side. Now it's, I didn't hammer them down because they were so uneven, but now that they're evened up, hammer them down, take another cut, and then set your dial to 0. Alright, now we can take them out and measure them. It's supposed to be 1.5 inches. Where are we at here? They're about 1.571. So now all we got to do is put them back in, hammer them down. And take 71 thousandths off. One rough cut and one finishing cut. And go ahead and deburr them while they're in the vise. Save yourself some time. And that's all there is to that. Okay, now we have square blocks to size. And that's how you do it. Like I said, you don't have to do this clamp routine if you know for a fact your parts are very close. But you know, I got a little wild in bandsaw, so there were a lot of irregular length parts. So just to make sure, it's always good to use this process, and you'll never scrap out a batch of parts because one of them's too short. So now we've got all 4 sides machined square into size. Now I have a whole lot of deburring to do, so I'll get started on that while I think about how we're going to cut that 45-degree angled edge. So once I get through these, we'll tear into that. So we got all the parts deburred. I have to be honest with you, when I turned the camera off, I went over and finished them up on the belt sander. I didn't file them all. That's the way it goes, I guess. Okay, where are we at here? We gotta cut a flat, 45-degree flat on these things. Let's pull out one of the prints here. They're all the same. They're still these three parts are still sharing the same features. So let's pull one of them out here. We have to cut a 45-degree flat, 1.25 inches from the center of this hole, which is located a 1/4 inch in from the two edges. So you notice this 1.25 inches here is a 2-place decimal. That means it has plus or minus 15 thousandths tolerance on it. So in my mind, that's laid out by hand with a ruler and mill to the line feature. If this were a 3-place decimal, it'd be a different story. I'd probably put the hole in first, put a gauge pin through the hole, and then locate off the edge of that gauge pin to get this 1.25 inch dimension, less half the diameter of the gauge pin. But since it's only 2-place, we're going to do it the easy way. Alright, let's see here. Let's just take one of these guys. First thing we need to do is lay out the center line of that hole, 1/4 inch in from each edge. So let's do that. Just got a scriber here. I'm just going to scribe a couple lines on it. 1/4 inch from each edge. That's the center line of the hole. Okay. Now I'm going to scribe a line. If I can find my square. Now I'm going to scribe a line diagonally from that mark across the part, like that. And then I'm going to measure over 1.25 inches along that diagonal. And put another mark. Draw a line through that. And that's the line we're going to mill to. I don't know if you can see that. There you go. Down here is the center line of the 1/4 inch of the hole. And here's our line across the top that we're going to mill to. So now that we have our angled cut laid out, we need to figure out how the heck we're going to cut it. There's lots of ways to do that. Kind of depends on what type of machinery and what type of fixturing you have. I think what I'm going to do is I'm just going to use a couple of V-blocks to set these parts in to establish that 45-degree angle. And then we'll just use the fly cutter to mill that corner off. I've got a couple V-blocks here. We'll just put those in the vise. Lay our stack of parts in the V. Okay, that sets them on 45 degrees. You'll need a little parallel here to make up the difference because the parts are a little shorter than the V-blocks are long, or the stack of parts are shorter. So just make sure everything's set down tight in the V-blocks. Make sure no burrs under it or anything. Tighten them up. Okay, everything looks good. One thing about this setup is we're not gripping on a whole lot of the stack or onto a whole lot of the parts here. So you have to be a little bit careful when we start fly cutting because we don't want to throw the parts out of the vise. So let's turn on the power here and machine them down. Alright, let's see. A couple ways we can do this. One's the right way, and one will throw them against the wall. If you look, the cutter rotates counterclockwise, so if we start here and we feed into the part, as soon as the cutter touches the part, it's going to be forcing the part in that direction. Well, we don't have a very good grip on the part, so what's going to happen is the whole stack's going to rotate, the cutter's going to grab and throw everything against the wall. Not a good thing. I think a better way to approach this is to come down here to the end and feed them in this way. Okay? That way, as soon as the cutter touches the part, it's going to be forcing the part against the solid jaw of the vise, not out the side of the vise. I think that'll work out a lot better for us. I'm still going to take it easy, you know, 50 thousandths, 100 thousandths cuts till we get down to our line. Let's see if we can do it without crashing. Work one down at a time here so I don't have to spend all my time running back and forth between the stacks. Not uncommon to machine to a line. I used to run a shaper, used to be a shaper hand in a tool and die shop, and we would always machine to a line. We'd split the line with the shaper. A lot of times that line would be curved for like dies, cutting edges of dies. So what you do when you split a line is you just watch the line, and when the cutter starts cutting into it, the line will get narrower. When that happens, that's a good indication of when you're on the center of the line. You can actually machine pretty close that one. Okay, we're about 20 thousandths above the line now. I'm going to set the dial on my table to 0 so I know where I am. And go over and take this other side down. Let's see if we can't split this line. Get where you can see the light shining off it so you can get a good view of it. Just kind of work down to it. You can see when the cutter cuts into it. Right about there. Can't show you that on the video. You have to see it with your own eyes. So just like that, got our 45-degree angle. Alright. Knock all the edges off, where they're clamped in the vise. Makes life a lot easier. Alright, starting to look like the real thing. That pretty much does it for this video. I think probably the next one we'll start drilling some holes, and well, I think we'll probably I'll go ahead and put the corner radii on in the next video along with the holes. See you then.